In the silence of space, orbiting at the edge of our world, a vessel of cooperation drifts gently around the Earth. It's not a satellite. It's not a ship. It is something far more rare. The International Space Station is the largest structure ever assembled beyond Earth. But it is also the most unlikely, a miracle of diplomacy, engineering, and vision, born not from conquest, but from a commitment to something greater than any single nation. More than 2 decades in operation, over $100 billion spent, more than 100 modules, trusses, and systems painstakingly delivered, not in one launch, but in many. It is a cathedral in space, built not to worship gods, but to explore the universe and ourselves. For centuries, the idea of a space station lived in fiction, in the writings of Jules Verne, in the dreams of Konstantin Tsiolkovsky, in the spinning rings imagined by von Braun. And then, the 20th century made space real. The Cold War gave us rockets. Fear gave us urgency, but dreams gave us direction. The United States and Soviet Union turned their eyes upward, first to orbit, then to the moon, then to permanence. In 1971, the Soviets launched Salyut-1, the first space station. By 1986, Mir, a modular platform, was launched, growing piece by piece in orbit. It became a milestone, humanity's first long-term orbital home. The United States, meanwhile, had focused on the Space Shuttle, a spacecraft designed to make space routine. But a shuttle is a vehicle, not a destination. NASA needed something permanent. In 1984, U.S. President Ronald Reagan proposed Space Station Freedom. It was a bold idea, a permanent outpost in orbit supporting science, industry, and commerce. But Freedom never launched. Politics stalled it. Budgets shrank. Critics mocked it as a paper station, ambitious on paper, but unaffordable in reality. Still, the idea refused to die. Then history intervened. The Cold War ended. The Iron Curtain fell. For the first time in decades, the superpowers looked across the divide and saw not a threat, but a possibility. Russia's space program, though battered by economic collapse, still held unmatched experience in station life. NASA, meanwhile, had the funding, the shuttle, and the need for a purpose. In 1993, they came together. What had once been 2 competing visions, Mir, 2 and Freedom, were merged. A new era began. This was not just a technological partnership. It was political, even poetic. Former enemies would now build together what they once raced to build alone. The International Space Station was no longer an idea. It was a promise. On November 20th, 1998, a Russian Proton rocket lifted off from Baikonur Cosmodrome. Aboard it was Zarya, meaning sunrise. It was the first module of the International Space Station, a power and control unit built by Russia with U.S. funding. 2 weeks later, NASA's Space Shuttle Endeavour launched Unity, a U.S.-made node. In orbit, Zarya and Unity met. The first connection was made, physically, diplomatically, and historically, and thus began one of the most extraordinary construction efforts in human history. How do you build a station in orbit? You don't assemble it in a hangar and launch it in one piece. No rocket is large enough. Instead, you launch it in segments. You lift each component, each module, truss, solar array, and cooling system, individually, and then assemble them in microgravity. It is a choreography of precision. Everything must fit. Everything must work. And you're building it while traveling 28,000 kilometers per hour around a planet that can kill you in minutes if anything goes wrong. Over the next 13 years, the ISS grew. Shuttle missions brought hardware and astronauts. Russian Soyuz rockets brought crews and supplies. More than 30 shuttle flights were dedicated to construction. Over 160 spacewalks were conducted, astronauts floating above Earth, tightening bolts, routing cables, replacing panels, installing labs. Every mission was a triumph over complexity. And then came the science. In 2001, the United States launched Destiny, its primary laboratory. Destiny housed hundreds of experiments, from fluid physics to cellular biology. Then came Quest, the airlock. Then the Pirs and Poisk modules from Russia, docking ports and science compartments. In 2008, Europe delivered Columbus, a compact but powerful lab packed with racks of experiments. That same year, Japan launched Kibo, the largest module, and the only one with its own exposed science platform, allowing research in the harsh vacuum of space. Every partner brought their strength. Canada contributed the robotic arms, Canadarm2, essential for grappling spacecraft and assisting spacewalkers. Italy helped construct key logistics modules. The European Space Agency launched automated transfer vehicles. Every nation became a builder. The ISS became not just a station, but a statement. Humanity assembled. To live on the station is to live between worlds. Astronauts sleep strapped to walls. They don't walk, they float. Water is recycled from breath and sweat. Waste is stored or burned in the atmosphere. Meals are packaged in pouches and eaten with a spoon. Time is tracked by mission control, not sunrise and sunset, which occurs 16 times a day. And yet, it becomes home. Crews celebrate birthdays and holidays. They call their families. They play music. They look out through the cupola, a 360-degree observation window, and see the entire world in a single view. No borders, no conflict, just Earth, fragile and full of life. In 2011, the Space Shuttle flew its final mission. The ISS had lost its primary construction tool. For years, Russian Soyuz rockets were the only way to reach it. But new players stepped forward. Private companies, like SpaceX and Northrop Grumman, began launching supplies. In 2020, SpaceX's Crew Dragon became the first commercial vehicle to deliver astronauts to the ISS. It was the beginning of a new era, one in which the boundaries between governments and industries blurred and access to space broadened. The ISS had helped build this future. More than 3,000 experiments have been conducted aboard the station. Some have changed how we understand aging, disease, and biology. Others have tested new materials, studied dark matter, or examined how fire behaves without gravity. In orbit, researchers can do what Earthbound labs cannot: observe the body, the planet, and the universe from a place in between. And all of it, every experiment, every data set, came from a station built, not for war or for profit, but for exploration. But the ISS cannot last forever. By the 2030s, its systems will be aging. Already, its modules show wear. Leaks occur. Repairs become harder. And yet, it endures. Plans are underway for commercial successors, smaller, cheaper stations. China has built its own space station. Others will follow. NASA aims for the moon, then Mars. But the ISS will always be first. The International Space Station was built in orbit, piece by piece, by hands from 5 continents. It has hosted citizens of 21 nations. It has lasted longer than any of its creators expected. And it has never fired a weapon, never claimed territory, never belonged to one flag. It belongs to all of us. In a century defined by division, the ISS is a reminder of what's possible when we build, not walls, but bridges. Not arsenals, but laboratories. Not boundaries, but frontiers. Floating above our world, It reflects the best of who we are and who we can become.